Hello, this is Scholar Strategies Math. Today in geometry, we're going to identify pairs of lines and angles. So let's start out with parallel lines. So parallel lines are one or more lines, and that do not intersect, and are coplanar. So they're on the same plane and they do not intersect. Here's line A and line B. That means line A is parallel. So parallel is that double, this sign here, to line B. Skew lines are lines that do not intersect and are not coplanar. So let's say we have this plane here, and we got a line in the plane, and then over the plane we have another line. So C and D are skew. And then parallel planes that do not intersect. So I got a piece of paper on the table, and then I got a floating piece of paper above the table. Transversal. A transversal is a line that intersects two or more coplanar lines at different points. So let's say we have two lines. They don't need to be parallel or nothing. There's just two of them. Actually, let's do it like this. The transversal will just be this red line here. Okay. Let me do one more picture. Alright, here's this line. And then there we go. There. Transversal is line T, and it intersects two or more lines at different points. So it intersects that line there and that line there. So line A, line B. So line T is the transversal. So we have a parallel postulate. If there is a line, so here's a line, and a point not on that line, so here's a point not on that line, then there is exactly only one line that can go through that point, and it will be parallel to the given line. And then there's a perpendicular postulate. So if we have a line again, and a point not on that line, then there's exactly one line that'll make this perpendicular that goes through that point. So two postulates, we accept them without proof. Alright, example 1. Think of each segment in the diagram as part of a line. Use the diagram to name lines or planes described. So lines parallel to AF. So let me put that in a different color. So green, AF. So we're looking at that line there. So they want lines parallel to AF. That means they're on the same, that they do not intersect, and containing point E. Okay? So let's do all those in green. So parallel to AF. So AF is that. So JE would work. So as you can see, those lines will never intersect. And then that's it. Okay. Trying to think of any others. I think that's it. Alright. Okay, now we're going to do skew. So we're still doing AF. Skew to AF containing point E. So skew means not on the same plane and does not intersect still. One of them would be no. Skew. So it actually would be this, but think of it as going above the object. So this is dashed right here. So they don't truly intersect, but they go on forever and ever. This is going below the object. This is going above the object. So that would be a line skew containing point E. Okay, let's do a different one. Lines perpendicular to AF containing point E. So AF perpendicular. Well, since there's no right angles here, we can't show any lines that are perpendicular. But so if we did have AF here, so here's A and F, a line perpendicular to that would be something that looks like this, and it would create right angles. Okay, part D, planes that appear parallel to the plane FGH. Huh. There's no G or H on here. A, B, C, D, E, F. Well, this pair of notes are kind of... Oh, okay, I'm guessing that this is supposed to be G, that corner there, and then this extra A is supposed to be H. E, F, G, H, I, J, yeah. F, G, H, I, J, okay. There we go. So FGH containing point E. So if we're looking at the plane FGH, we're looking at this plane here. So that would be, so here, 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 and that'll extend outward. And so if you see that there, so that would be AE. Or plane, sorry, plane ABD. So here's FGH, here's ABD. Actually, it should be ABC. Yeah. ABC. Wait. Let's try a different one. That one was a little bit hard. Okay, part A, checkpoint 1. Looking at this cheese block ramp. Lines parallel to MN and containing point J. We have LJ. Yep. So we have MN. Something that's parallel and on the same plane is JL. Part B. Skew and containing point J. That would be KO. Oh, sorry. Containing point J. JK. So see how that goes straight up in the air. It'll never intersect. Think of this as going to the back. They will never intersect. But they're not on the same plane. So we got JK. Lines perpendicular to MN. Containing point J. That would be JN. See how that's a 90 degree? Right? Now we're not supposed to assume 90 degrees. So they would give you that this is 90. But that's the closest thing I can get. That includes point J. And then planes that appear parallel to M and O. So M and O. And then we have JKL. So plane JKL. So that one's a lot easier to see. So we see that triangle there is it's one plane, and then that triangle is another plane. They don't intersect. They're actually parallel. Alright, let's go down here. Angles formed by transversals. Okay, here we go. So, you're going to see this slide a lot. So if you have two lines being cut by a transversal, so here's line 1, and then here's line 2. Let's go back to green. Green. So here's the transversal T. What it does, it makes two intersections, and it makes angles. So we have 1, 2, 3, 4, 5, 6, 7, 8. And the corresponding angles, so if you think of them as the two different intersections, they would be the same position. So if I looked at the first intersection, the top intersection, angle 1, that position, that's the same position as angle 5. So angle 1 and angle 5 are corresponding. Angle 2 is in the top right. So the top right of the bottom intersection is angle 6. And then we have angle 3 and angle 7. And then angle 4 with angle 8. Okay. Let's make another one of those. Okay. So angles that lie, so alternate interior. So think of it as, so let me put the interior angles, actually let me label all the angles. So we have 1, 2, 3, 4, 5, 6, 7, and 8. The interior angles I will mark in, let's use red. So 1, 2, 3, 4, 5, 6. So the interior angles are all the angles on the inside. So 3, 4, 5, 6. Alternate interior means on the inside. So interior means inside. Alternate means on different sides. So angle 3 and angle 6 would be alternate interior. Angle 5 and angle 4 would be alternate interior. Alright. And then the alternate exterior would be angles 1 and 8. Angles 7 and 2. Those are alternate exterior. Exterior means outside. So notice how they're on the outside. The green ones are on the outside. The red ones on the inside. Red is interior. Green is exterior. And then alternate means different sides of the transversal. Okay. Let's draw a different one. So let's have 2 green lines this time. Being cut by a transversal. Okay. And we're still going to have 1, 2, 3, 4, 5, 6, 7, 8. So all those are all the different angles. Consecutive interior means same side on the inside. So remember, the inside are the ones in the middle, 3, 4, 5, and 6. So same side. So same side in the inside is angles 3 and 5. Angle 4 and 6. So that's what it means to be consecutive interior. And then consecutive exterior, that would be angles 1 and 7. Same side on the outside. Same side of the red line on the outside, and then angle 2 and angle 8. Consecutive exterior. Okay. Example 2. Name a pair of parallel lines. Okay. AB is parallel to CD. And they will use this marking here, this arrowhead. So that arrowhead and that arrowhead represents that the line AB is parallel to the line CD. So once again, that arrowhead tells us that these lines are parallel. Name a pair of perpendicular lines. That would be the line AC with AB. So remember, the upside down T represents perpendicular. When we look at AB and AC, you can see that they make a right angle here. So this right angle shows that they're perpendicular. Is AB perpendicular to BC? So is the black line here perpendicular to BC? Well, that's an obvious no. It does not form right angles. There is no right angles. Another way to look at it, what is this? So another way to look at it is AB is already parallel to CD, therefore it can't be parallel to, actually, no, yeah, there's no right angles, sorry, yeah, that's it. And that, yeah, A, B, and CD, obviously not right angle. Example 3, use the diagram to identify all pairs of corresponding angles. Okay. So we have two lines, boom, boom. So the X are the two lines, and we're cut by the red transversal. So we have two different intersections. Okay. So let's go through this. Corresponding angles means same position. So I have two intersections. I have 1, 2, 5, and 6, and then I have the intersection 3, 4, 7, 8. So those are my two intersections. If I can get this right. There we go. So here we go again. Corresponding angles, same position. So angle 1 is in the top left of that intersection. So the top left of the other intersection is angle 3. Angle 2 is with angle 4, same position. And then angle 5 and angle 7. And then angle 6 with angle 8. Okay, alternate interior. So the inside this time, let's mark that in green. So let's have okay, inside for green. And then outside for anything that's outside there. So 2, 3, 6, and 7 are interior angles to be alternate. They're on different sides. So angles 2 and angle 7. So it's not angles 2 and 6 because they're in the same intersection. So you want to say, so you want to use the two different intersections each time. So angle 3 and angle 6. So alternate exterior angles, that would be angle 1 and angle 8. And then angle 5 with angle 4. Consecutive interior means same side on the inside. So angles 2 and 3. And then angles 6 and 7. Consecutive exterior 1 and 5. 4 and 8. All right, part A, name the angles shown. So 3 and 4 are on the inside, and they're on the same side, so we call that consecutive exterior. Okay. These ones are on, or sorry, consecutive interior. Interior, I was thinking of the next one. So these are on the outside, so that's exterior. And then they're on opposite sides of this transversal. So they are alternate. Alternate means different side. Exterior means outside. Okay, and that's all for today. That was a long one.